Alright, so this is a video key for topic 1. This whole thing right here, you just plug into the calculator. This is 3 times 10 to the 40 squared minus 5 times 10 to the 80. So when you plug that into the calculator, your calculator is going to give you 4e80, which is the same thing as 4 times 10 to the 80th power. Okay, so that's the answer for the first one. For the second one, you have 3 times n plus 1. So they're saying anytime you see this right here, you should think scientific notation, which is you have a number between 1 and 10 over here, and then this is going to be times 10 to an exponent. So here, if it's 3 times 10 to the n plus 1, you move the decimal. There's no decimal, it's always at the back. You move it one place to the right, so that becomes 30. There's no number there, right? That's a 0. So this is going to be 30 times 10 to the n. They are both the same thing. And the reason why we're doing that is because over here, the exponent is times 10 to the n times 10 to the n power, and this is 4. So you can go ahead and subtract this now. So when you subtract it, 30 minus 4 gives you 26 times 10 to the n power. We don't know what the n power is, so we're just going to leave it like that. And now we're going to go backwards, right? So we're going to go ahead and move this, because this number right here is not between 1 and 10, like we said that this has to be. So the decimal point is at the end. You're going to move it 1 to the left. So when you do that, this is going to be the same thing as 2.6 times 10 to the n plus 1, okay? So these two are equivalent. For the next one, it's also a scientific notation question. So over here, you're now dividing. So 6 times 10 to the n divided by 8 times 10 to the negative n. So now when you're dividing with fractions, remember that when you had like x to the 5th divided by x to the 3rd, this is a separate question. You subtract the two exponents, so 5 minus 3 is 2. That's going to be x squared. So over here, you're going to do something similar. So 6 over 8 can reduce. We'll talk about that in a second and what that's equal to. Times, and then here you're going to subtract those two exponents. So times 10 to the n minus a negative n. Okay. So 6 divided by 8, when you plug that into the calculator, is 0.75, reduces to 3/4, which is 75 cents, times 10 to the n minus negative n is the same thing as n plus n, which is 2n. And it says they want it in scientific notation, which is what all of that right there says. So you're going to move the decimal over one place to the right. So that's going to be 7.5 times 10 to the n, so this is 2n, and so this is going to be 2n minus 1. So final answer. So remember, when you're moving the decimal to the right, you subtract 1. When you're moving it to the left, you add 1, okay? For number 4, find the 25th term. This is a formula. So the formula is un is equal to u1, that's u1 plus parentheses n minus 1d. So the 25th term is what we're looking for. So u25 is equal to u1 is the first term, which in this case is 20, plus they're asking you for the n, which is 25, because that's the number of terms. So 25 minus 1 times the common difference. The difference is the number that you add to get to the next number. In this case, we are adding a -3. So we're going to multiply this by -3, plug all of that into the calculator, and you're going to get that the 25th term is equal to -52. There are other ways to do this on the calculator, but that is the way using the formula. Okay, ask me if you need help with that. All right, so this is about a minute mark. So we're on the 5th term. The 5th question. So we're doing pretty well. So the next one is arithmetic sequence. So they're telling us it's arithmetic. The first term is 21, and they're telling us that the last term is equal to 1602, and they're saying that the common difference is 17. Okay, so we have all the information that we need to know, and they're asking us how many terms now. So again, we're going to use that same formula, u1 plus n minus 1d. Notice I'm showing work for every question. They're telling us that the nth term is 1602, so you're going to plug that in, is equal to u1 is 21 plus, we don't know our n, so we're going to leave that alone, n minus 1, and they're telling us the common difference is 17. All right, so you could subtract 21 from both sides. You could do this algebra 1, 1602 minus 21 is 1581 is equal to n minus 1 times 17. Divide both sides by 17. So I'm going to go divided by 17, and I get 93. So I get 93 is equal to n minus 1. Add 1 to both sides, and you get n is equal to 94. Okay, so final answer. There's another way to do this on the calculator using math. You go down to solver, enter equation 1, right? So going back to this right here, this is equation 1, so we could put 1602. Equation 2 is going to be the right side, which is 21 plus parentheses, instead of n, let's just use x minus 1 times 17, and then hit OK. And here, for x equals 0, hit alpha, solve, and it gives you 94. Okay, either way you do it, you still get the same answer. Fourth term is 10, so U4 is equal to 10, and they're telling you that the 10th term, U10, is equal to 34. One way to do this is by guess and check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're telling us that the fourth term is 10, so this is U4, and they're telling us that the 10th term, U10, is 34. So you could look and see what the pattern is to get from 10 to 34. If you can find it, great. Okay. If you can't do it that way, the other way to do it is by using the formula. Un is equal to U1 plus n minus 1d. So they're telling us U4, and the fourth term they told us is 10. So you could put 10 in here. U1 we don't know, so we'll leave that alone. Plus the number of terms that we have. We're looking for the 20th term, but for right now we have 10th term. No, the fourth term. Let me back up. So here we have n minus 1, right? So since this is the fourth term, we're going to do 4 minus 1. And then the common difference we don't know, so we'll leave that alone. And then we're going to set up another equation for the other term that they give us, which is the 10th term is 34. So we're going to put 34 is equal to, we still don't know U1, plus they gave us the 10th term, so this is going to be 10 minus 1 times the common difference. Okay, this is a system of equations. You can rewrite this as 10 is equal to U1 plus 4 minus 1 is 3d, and 34 is equal to U1 plus 10 minus 1 is 9d. Okay, so you could take this, plug this into the calculator by doing apps. I don't have it on my calculator, but apps polysimult 2, which is, I believe, choice 8 or 9. And then you're going to go into, just hit enter, and then you're going to go into the one that says simultaneous equations, and you're going to type in this right here, the coefficient here. There's an imaginary 1, so you're going to type in 1, and then you're going to type in 3, and then where the line is, you're going to type in 10. So basically, you're taking this 10, putting it on this side, so equals 10. And then for the second one, you're going to type in 1. Here is 9, and then this number is 34. And then you hit solve, which is a graph, and it'll give you the two numbers. So it'll give you that U1 is equal to -2, and it'll give you that the common difference is 4. Okay, so that is the two answers that they're looking for. Or like I said, you could do this by hand, try to figure it out. But remember, you have a minute. Okay. For the next one, find the sum of the 30 terms. This is a straight calculator, straight formula kind of question. Here, the common difference is equal to -3 because you're subtracting by 3, and we're looking for the sum of the first 30 terms. So S30 is equal to, I would use the longer formula for this one. So it's 30 divided by 2, parentheses, 2 times the first term is 13, plus we're looking for the 30th term, minus 1, and then times the common difference, which is -3. Right, so I'm going to close this parentheses, close the bigger one, plug all of this into the calculator, and you're going to get negative 915, which is the answer for number 7. Okay. All right, so for the next one is also a calculator question, but in this case, I would use the second formula. We're looking for the sum of the first 20 terms is equal to the n is 20 divided by 2. And then here you put the first term, which they are giving us. The first term is 4, plus the last term, which is the 20th term, which is 130. And then plug that into the calculator, and you get 1340. Okay, so these questions are straight calculator. They should be pretty easy. Determine the first term and the common difference of an arithmetic sequence. Anytime they give you n here, right, you don't plug this into a calculator because we would need that to plug into the calculator. So you would set up a table. So you're plugging in r here with the numbers that they give you from 1 to 3. That should be enough to find a pattern. And then over here, you're putting the rule, which is 5r plus 11. So plug 1 in, 1 times 5 is 5, plus 11 is equal to 16. 2 times 5 is 10, plus 11 is equal to 21. 3, when you plug that in, you're going to get 26. And we can see that the pattern here is plus 5, okay? So they want what? They want the first term, which we found, okay? So U1 is equal to 16, and we found that the common difference or the pattern is going to be plus 5. So those are our 2 answers. This one is straight calculator. You plug this in, so turn that calculator on. You need it to work. Hit math, go all the way down till you get to the E summation right here. Hit enter, and you literally just type it in. Instead of, we're going to put X is equal to 1. At the top, we're going to put 100. I know that they don't have the X equals here, but it's okay. And over here, whatever variable we used here, we're going to plug in. So this is going to be 5. Instead of r, I'm just going to put x plus 11. If you wanted to go ahead and find r, you could do that. That just might work. So 26,350, right? So 26,350. And we did this using the GDC. Okay. All right, next one. First day of training, Ahmed runs 500. So U1 is equal to 500. Each subsequent day, he runs 100 more. So the common difference is 100 more. So we're going to go ahead and look for the 28th day. So we're looking for U28. So again, we're going to go ahead and we're looking for in total. So that means that it's going to be one of the S formulas, the summation formulas, and we're looking for the 28th day. I would use the longer formula, 28 divided by 2, parentheses, 2 times the U1 is 500, plus the common difference is going to be 100 times n minus 1, right? So 28 minus 1. Plug all of that into the calculator, and you're going to get that the total is going to be 51,800 meters. Okay, 51,800 meters. All right. Juanita invests $300 at 2.4% simple interest. As soon as I see this, move the decimal 2 places to the left. So this is equal to 0.024. And it's simple interest. How much will be in her account after 10 years? This is principal times rate times time. That gives you the amount of interest. So let's do that. So principal, we're putting in 300 times our rate, which is 0.024, times the time, which is 10, and you hit enter in the calculator, you're going to get 72. That is the interest. How much will be in the account after 10 years? We're going to take the original amount, which is 300, and we're going to add that 72 to it. So that's going to be $372. Okay. There are different ways to do this question, but that's the one that I'm going to explain. All right, for this one, a lot of people got tricked with this one. First, we need to find a common difference, but it's not steady. Like, for example, here the common difference is 1.1. Here it's 0.8. Here it's 0.8. So what I just did is I found an average of them, 1.1 plus 0.8 plus 0.8 divided by 3, and you get 0.9. So that's the common difference. So this is our difference. It says by modeling estimate the velocity when t is equal to 0.5. You could just continue this, get 0.4, 0.5, and then figure out what this number is, or you could use the formula. It's up to you. I'm just going to go ahead and use the formula. Or you could just keep adding 0.9. That's fine. But over here you have you're looking for where t is equal to 0.5. That is the 1, 2, 3, 4, 5, 6th term that we're looking for. And you plug in the first term, which is u1, which is 0, plus n minus 1, right? We're looking for the 6 minus 1 term, which is the fifth. 0.5, and then the common difference we just found out is 0.9. So when you plug this into the calculator, you're going to get 4.5 meters per second. Make one criticism of the model. There's a bunch, right? So there's too little data for us to figure out. Is it arithmetic? Too little data. I'm only going to write one, but I'll say the others. There's a whole bunch. Is it arithmetic? We don't know, right? Even though it says it's arithmetic, in real life, this may not be. The ball is going to also hit the ground eventually. The ball is dropped, right? So eventually it's going to hit the ground. So this is not realistic. It's not realistic, right? I said I was only going to write one, but it's okay. All right. Find the 10th term. So for this one right here, again, is straight formula. The formula is given to you in the reference sheet or in the formula booklet, so you don't need to memorize it. Our U1 is 32. Our common ratio in this case, okay, so I noticed that the numbers are switching signs, which means that my ratio is going to be a negative number. And then okay, it looks like I'm dividing by 2 here, which means that I am multiplying by a half. So remember, dividing by 2 is negative 2 is the same thing as multiplying by negative 1/2. Dividing by negative 2 is equal to multiplying by negative 1/2. And remember, the common ratio is the number that you are multiplying by to get to the next number, okay? And we're looking for the 10th term. So U10 is equal to, first term is 32, times our ratio, and again, this is straight from the formula booklet. Please find the formula booklet, negative 1/2, and then our exponent is going to be 10 minus 1. Plug all of that into the calculator, and you're going to get negative 1/16. Okay, if you don't get any of these, please ask. Find the number of terms in the geometric sequence. So again, I look for a pattern, so it looks like my ratio is 2. My first term is 1. And my nth term is equal to 4,096. So I can go ahead and use my same formula, 1r to the n minus 1. I encourage you to put the r in parentheses. So they're giving us the nth term, which is 4,096, is equal to, the first term is 1 times, the ratio is 2, and we're looking for the n minus 1. Okay, 1 times anything is itself. So I have 4,096 is equal to 2 to the n minus 1. I would use log here. So this is the same thing as log, with the base goes on the bottom. The log of the answer, which is 4,096, is equal to n minus 1. Right? The exponent is the answer to a log, so n minus 1. So to get the n by itself, I add 1. So log base 2 of 4,096 plus 1 is equal to n. So I go to my calculator right here. Let me move this over. How I get this little 2 on the bottom, I can't just hit log, okay, because it won't allow me to put the 2. So I hit math, go down to the bottom to log base, hit enter, and this is where I can put my 2. I put my 4,096. I put plus 1. And I get 13, okay? So n is equal to 13 is my answer. That's the number of terms. 16, a geometric sequence, third term, so U3 is equal to 16, and the 7th term is 256. So now remember, this is geometric, this is not arithmetic. So this is not a linear equation that we can use that system solver for. So the 7th term is 256, okay? Find the possible values. So remember the formula, U1 r to the n minus 1. Let's plug in what we know. So the third term is 16. So 16 is equal to U1, we don't know, right? Times the ratio. We don't know that either. And then we have n minus 1. So in this case, our n is 3, right? So we're going to do to the 3 minus 1 power. And then the other thing that they gave us is 256. We're going to follow suit for the second one. 256 is equal to U1 times the R to the 7 minus 1 power, okay? I notice that if I take these two and I divide them, my U1s cancel out. So then that way I can find out what my ratio is. So 256 divided by 16, if I plug that into my calculator, 256 divided by 16, I get 16 as my answer. So 16 is equal to, and again, the U1s cancel out. So I have R to the 7 minus 1 is 6, right? So I'm doing R to the 6 divided by R to the second. Remember, when you're dividing with exponents, you subtract them. So that's going to be R to the fourth. And to get the R by itself, you find the fourth root, right? The fourth root of 16, which is plus or minus 2. So plus or minus 2 is equal to R. So those are the possible values of what the ratio is going to be. And then now they want us to find the first term, so I could plug it into my formula. So I have UN is equal to U1 times R to the n minus 1. So let's go ahead and plug in this one right here. Okay, so my U3 is 16, so 16 is equal to U1. I don't know. I just found out that my ratio is either 2 or negative 2. I'll just use 2 for sake of argument. And this is going to be third term, so 3 minus 1. And I can pretty easily solve this and get U1 is equal to 4. Okay. If you don't know how to solve that, you could always plug this into Y1, plug this into Y2, and see where they intersect. And they'll intersect in 4. Find the sum of the first 8 terms. This is a calculator / formula question. Same thing as before here. Here we're dividing by 3, which means that it's the same thing as multiplying by 1/3. So our common ratio is 1/3. There's no sign changes, and our U1 is 162. Okay, so I'm going to plug that into my sum formula because they're asking us for the sum. So the sum of the first 8 terms, so sum of 8 is equal to 162, parentheses, 1 minus our ratio, which is 1/3, to the 8 minus 1 power. No, just to the 8th, my bad. Divided by 1 minus 1/3. Okay, so all of that goes into the calculator, and your answer is about 243. Okay, 3 significant figures. Number 18, determine the first term in the common ratio, right? So we have, as soon as we see the n right here, we know we're going to have to make a table. So we have r, and we have 2 times 5 to the r power. So we're looking for the first term, and then we're looking for the common ratio. So the first term, plug that in. 2 times 5 to the first is going to be 10. When you plug in 2, we're going to get 50. When we plug in 3, we're going to get 250. Okay, so our U1 is very easy. It's 10. It's right here, right? And this is going to be keeping on multiplied by 5. So our common ratio is 5. Okay, so those are our 2 answers that we're looking for. All right, we're making good on time. This is straight calculator. Summation, right? X equals 1, 10, 2 times 5 to the r. Well, in this case, since I didn't use r, I used x. Plug all of this into the calculator, and you're going to get that your answer is a big one, 24,414,060. And to show work for this, you could say that the first term is equal to 10, and that the ratio is equal to 5. How do I know? Because we just did this, the problem above, right? Okay, it's right there. So as soon as you see grows by 20% each day, you should think geometric sequence. And you should also think that, okay, what is this growing from? It's growing from 100%. So 100 plus 20% is 120%, which as a decimal is 1.2, okay? So those are some things that you should think of initially, right? It says there are initially 50,000 bacteria. So this is our U1 is 50,000. Find the number of bacteria in the dish after, look at this, after 12 days, which means that we are looking for the 13th day. We are looking for U13, okay? So let's plug that into our formula. So U13, we're going to plug it into the same formula that we've been using in question numbers 18. So the U13, the 13th term is equal to the initial, which is 50,000, times our common difference, I'm sorry, our ratio, which is 1.2, to the n minus 1 power, so that's going to be to the 13 minus 1 power. Plug all of that into the calculator, and you're going to get 445,805. So this is your answer for number 20. Why can this not continue? Right, yeah, so this is a bacteria that's growing in a dish, right? So it is unrealistic to say that the bacteria will never stop growing, right? It's unrealistic to say bacteria grows indefinitely. All right, look at my spelling. All right, so $2,000 or 2,000 pounds is invested after paying 4%, so 0.04 is our rate. Okay, this is how much is invested. As soon as I see something like this, compounded monthly, that means that this is the n is equal to 12. As soon as I see this, the words TVM solver should come to mind. Okay, so we're going to go ahead and plug this into our TVM solver. Our n equals, right? So this is the number of years, and it's compounded monthly. So we're going to put into that 12 times 10 into the n. Our I percent, you could leave it as 12 times 10, it'll do the math for you. Our I percent is going to be 4 because that's our percent. You didn't have to change this because it's TVM solver. So our I is going to equal 4, and they want it as a percent. That's why we don't have changes to a decimal. Our present value is right here, right? 2,000. So since we are investing this amount, I'm just going to put negative 2,000. And then the future value is what we're looking for. So for right now, we're going to leave that alone. And then our P over Y is going to equal, right? It's compounded monthly, so that's going to be 12. And our C over Y is going to be the same thing. That's going to be 12. So then you're going to go to the future value. You're going to hit alpha enter or alpha solve, and you're going to get the answer, which is $2,981.67. So you have to round it correctly. You could use the formula that's in the formula booklet. See me or the answer key if you want to learn how to do that. But final answer, $2,981.67. Okay, make that a little bit neater. 67. And again, this is pounds, so however you do that little, hey, that's not bad. Okay. Samira wants to invest $1,000. So this is our present value in an account paying I%. So now we're looking for this compounded quarterly, which means that our n is equal to 4. She wants to have, so this is our future value, 1,500 in the account after 8 years. Okay, so that's the number of years. So our n is going to be 8 times compounded quarterly, which is 4. Our I% is what we're looking for. Present value is 1,000. I was putting colons, so I'll just put 1,000. So she's investing $1,000, so I'll just put negative 1,000. Our future value is, we want 1,500. Our P over Y and C over Y is both going to be 4. Okay, go to alpha, go to I, go to alpha, enter, and you're going to get 5.1%. Okay, so that is our answer for this one right here. Next one, James invests $100. We're looking for double, so that means that the future value is going to be $200. That's what we're looking for. So let's go ahead and see what each of them is. We don't know the n. We are looking for that. I've been just indicating that by putting a line. Our I% is going to be 2.1. Our present value is 100. Our future value is 200. Since one of them has to be negative, I'll just put this as 200, negative 200. Our P over Y and C over Y is going to be 1 because annual interest. Okay, so annual is 1. And then you go here to the N, hit alpha, enter, and you're going to get 34. This is about 34 complete years. And the reason why is because when you plug it into the calculator, you're going to get 33.35, and it's saying how many complete years. So there, that is about 34 complete years, which is the answer for this question. Car suffers from annual depreciation. This is the formula: A equals small a, 1 plus or minus r to the t power. If it's growing, you're going to use the plus formula. If it's decaying or depreciating, you're going to use the minus formula. So the initial amount is 40,000. So you put 40,000 times, and again, we're decaying, so it's going to be 1 minus. Our rate is 12%, so that's 0.12 to the t power, which is 4. Plug all of that into the calculator, you're going to get a number that looks like, I don't know why all of a sudden my thingy thing, 23,987.8144. So we're going to go ahead and round this to about 3 significant figures, $24,000. Okay. $24,000 is the answer for number 24. All right. All right, we're doing good on time. We have 31 minutes, 25 questions. All right, so he's investing $2,000 at 3.2%. There's an inflation rate of 2.4. So first thing for the percent, you have to do 3.2 minus 2.4, which gives us 0.8%, accounting for inflation. And then our N is equal to 5. Our I, we just found out, is 0.8%. Our present value, right? He's investing $2,000, so minus 2,000. And the future value is what we're looking for. All right, so I'll put a line for right now. The P over Y, annual, right? So that means that we are going to put this as 1. And then you hit alpha enter right here, and you're going to get about, we're rounding this to the nearest dollar, so we're going to get about $2,081 is our final answer for number 25. This one right here is literally just straight calculator, so plug it into the calculator. This is 2 to the negative 2 to the negative 2, okay? And when I plug that into the calculator, I don't know what all of this is, but whatever. Plug it into the calculator, and you're going to get 16 as your answer, all right? Maybe my battery is dying on this. It's okay. 2x to the third, right, means that you're going to do 2x times 2x times 2x, because you're doing it 3 times. 2 times 2 times 2 is 8. X times x times x is x to the third, okay? Or you could do it as 2 to the third, which is 8, and x to the third, which is x to the third, okay? Either way you do it, same answer. This one right here, is a straight log question. So 10 is our base, so you put that 10 down. It's our base. The answer to a log, I don't know what that was. The answer to a log is the exponent, so I'm going to put the x here, right? So we're solving from x for x, which is what we want. And then k goes in the missing spot. So this is our answer. You're done. All right, so in the calculator for the next one, where you see the ln, the opposite of ln is e. These two are opposites of each other, so you can use the calculator to help you remember that. So to get rid of the e, you can ln both sides. So ln of e to the 2x minus 6. You just need to remember that e is a number like pi. It's an irrational number, it keeps on going. So if I ln the left side, I also have to ln the right side. And as soon as I do that, my ln and the e cancel each other out. So I'm left with 2x minus 6 is equal to ln of 5. And I'm going to get the x by itself by adding 6, add 6. So this is ln of 5 plus 6. Don't put 11, okay? They're two separate things. So this cancels out. So I'm left with 2x is equal to ln of 5 plus 6. And then to get the x by itself, divide both sides by 2. Divide by 2. If I want to, I can leave my answer like this. X equals ln of 5 plus 6 divided by 2. I could leave my answer like that. If you wanted to do what's called like Band-Aid method, you can. So you could say that that is the same thing as x equals ln of 5 over 2 plus 6 divided by 2 is 3. You could say that as well. Either of these two answers work, okay? Either of these two work. All right. I think my battery's dying, whatever. This one right here is straight calculator, so go to the calculator. and just type it in. So let's turn the calculator on, that would help. ln, so here's the ln button, ln 10, we're going to close those parentheses, plus, to get log base 10 of e, you hit math, go all the way down to log base, enter, and then we put the 10 here, and then the e is right here above the division symbol, so second division, and then hit enter, and it gives you that number. Okay, so I'm going to round this to about, let's go back to black, 2.74. Okay, is my correct answer for number 30. Round this to 3 decimal places, right? 1, 2, 3, which means that I'm looking at the 6. 5 or above, we're going to give this number right here a shove. 4 or less, we're going to let this number right here, the 0, rest. So since it is 5 or above, this is going to go, the 0 is going to go up to 1 up, which is 1. Everything to the left is going to stay 0.01, and everything to the right is going to drop. Okay, final answer. Round this to 3 significant figures. So 3 significant figures, 105, which means that I look at the number to the right, and then that 5 stays, because 4 or less, we're going to let this number that I just underlined rest. So it's 105,000. Okay. Final answer. X is measured. All of these are pretty straightforward. So for this one, 500,000 is 1 significant figure. Y is 4 significant figures. Whichever the one is the smallest one, that's what you're going to round your answer to. So we're going to round to 1 significant figure. That is the one that we're going to round to, because it says calculate your answer to an appropriate level of accuracy. So we're going to take the two numbers, x times y, and we're going to multiply them. So 500,000 times 0.1235. We're going to put that into the calculator, and that's going to give us about 61,750. And again, since I'm rounding it to 1 significant figure, that's going to be about 60,000. So my final answer for this question is 60,000. Okay. The next one, if x equals 12.45 to 4 significant figures, find the range of values that are possible. This is a common question. So to 4 significant figures, that is going to be, I'm looking for any numbers that can round to 12.45. So 12.445 is going to be the smallest number. That's going to round to 12.45. Right, because if I look at this number right here, 5 or above, I'm going to give this number of shoves. That's going to become 12.45. And so it's going to be including that. And then the highest number that I can pick is going to be 12.455. But since this one right here is going to round to 12.46, I don't put the equal sign right here. So this is going to be my range of possible numbers for x. An angle is 38 degrees. This is exact. A student estimates that the answer, so this is going to be the measured or the approximate. Find the percentage error. This formula is in the calculator, well, in the formula booklet. So I'm going to do absolute value of 45 minus 38 divided by 38. Close that absolute value times 100. And I plug all of this into the calculator, and I'm going to get about 18.4%. is my percentage error. 36, side of a square is 7 centimeters to 1 significant figure. So 7 times 7, the area of this is 49. Find the maximum percentage error if the area is quoted as 49. Okay, the maximum percentage error. So this also is very similar to the question that we did right here for number 34. So what is the smallest number that can round to 7? We have 6.5 can round to 7, right? Less than or equal to x, less than 7.5, right? So 7.5, any number up to 7.5, like 7.449, 7.499, right? All of those round to 7.5, but 7.5 does not round to 7.5, it rounds to 8. So I'm going to find the area of each of these, right? So 6.5 squared, 6.5 squared, because it's a square. When I square that number, I'm going to get 42.25. And if I take this largest number right here, the 7.5, and I square it, I'm going to get 56.25. So now I'm going to find the percentage error for each of these compared to the exact value of 49 and see which one is larger. Okay, so I have to do 2 percentage error questions. So I'm going to start with the 56.25. So I do 56.25 minus 49 over 56.25 times 100. And when I do that, do I have any space here? I'm going to get 12.9%. And then when I plug in, instead of the 56.25, I plug in the 42.25, 42.25 minus 49 over 42.25 times 100. That percentage error is going to be 16.0, so I'm looking for the largest one. So the largest percentage error is going to be 16.0, okay? Because 16.0 is larger than 12.9. All right, Jenny calculates the probability of getting 5 heads when flipping a coin 8 times and gets 2.5. Nope, that can't happen. Why? Because the high percentage, right, probability, it has to be less than or equal to 100%, right? Which is going to be the same thing as 1. So the probability cannot be higher than 1. So she's wrong. She cannot be correct because probability has to be less than or equal to 1. Okay. Jamie borrows $1,000, 3%. So all of these again scream TVM solver. So here n is equal to 5. I percent is going to equal 3. Our present value is going to equal 1,000. So I'm going to put negative 1,000 because that's going away from her. For this one right here, we're looking for the payment. So PMT, this is what we're looking for, is equal to, and future value, we want the future value to be 0. And the P over Y, this is annually, right? So that's going to be 1. And then you plug this into the calculator and you hit alpha, enter, and you're going to get about $218.35, which is the answer for this question. All right, so Kumar invests $100, so this is going to be our present value. So present value is negative 100. All right, so here, beginning of each year, so this is key. At the beginning of each year, this person invests in an account that pays 2.3% interest, and we're looking to see what is the investment at the end of 10 years. Give your answer to 2 decimal places. All right, so our N is going to be 10. Our I is 2.3%. So we're going to put that down. Our present value is the negative 100. Our payment, right? This is how much we're paying. So our payment is also going to be negative. So we're paying negative 100. Our future value, this is what we're looking for. And then our P over Y and our C over Y is going to be 1 because it says each year, okay? So our future value, when you hit the alpha enter, you're going to get 1,235.64, which is our answer for this question. Question number 40 is also a TVM solver, so N is equal to 30. Our I percent is going to equal 4%. Our present value is going to be, Heidi has $50,000, so minus 50,000. Our payment is going to be what we're looking for, right? And then our future value, we want the future value to be 0 at the end of it. And our P over Y and our C over Y are both going to equal 1. So our payment is what we're looking for, right? So it says how much can she withdraw at the end of each year. So we're going to hit alpha enter with this, and we're going to get $2,892, and that is how much she can withdraw at the end of each year. And it says give your answer to the nearest dollar, which is why I rounded it like that. All right. Question 41. This is straight calculator. This is apps. Again, I don't have it on this model of my calculator, but apps PolySimult 2. And then what you have to do is option number 2, which is simultaneous equations solver. And then you're putting in the coefficients for this. Oh, this is our order of 3 and 3 equations. And then you put your answer in fraction or decimal, it doesn't really matter. Hit graph. Ask me for help on this one if you do not get it. So this is going to be, you're going to plug in 3, 2, 4, -1, 1, 1, 1, 0, 10, 7, 4, and 6. And then hit solve, and you're going to get x equals 1, y equals 0, and z equals -1. So those are your 3 answers for 41. For the last one, this is also an apps polysymult thing. So apps, go to polysymult 2. And in this one, you're going to hit option number 1, which is finding the roots. So polynomial roots solver. And then the degree here, if you look for the degree is the highest exponent, which in this case is 3. So your degree is 3. And then your 3 values are x equals -0.303, x equals 1, and x equals 3.30. Right? Those are your 3 answers for 42. All right, great job. Talk to you soon. Bye-bye. Bye.